Hello students, welcome to our lesson today. In our lesson today, we shall be looking at isotopes. This is Teacher Mercy and this is a chemistry topic in Form 2 under the structure of the atom. In our last lesson, we learned about the atomic numbers and mass numbers. In our last lesson, we learned about the atomic numbers and mass numbers. We said that an element in the periodic table is written as, shown, where the chemical symbol of the element is supposed to be here in the middle, and then we are supposed to have a superscript as our atomic mass, otherwise called the mass number, and our subscript is supposed to be the atomic number. I've said the superscript is the atomic mass or the mass number, and the subscript is the atomic number. Let us look at the picture below. In this picture, we can see that we have an element, chlorine, and this chlorine on the right and on the left almost look alike. Our element here is chlorine. We are saying chlorine because the symbol of the element is the same. Cl, the symbol of the element is the same. Cl. Now, if we look at the bottom where we are having our subscript, we can see the subscript is the same, 17. And remember, we've said our subscript represents the atomic number. So these two elements or these two atoms have the same atomic number, and our atomic number is 17. At the top, we have superscripts, and our superscripts are not the same. We have one superscript in chlorine 1 being 35 and in chlorine 2 being 37. Do you remember how we defined the atomic number? We defined the atomic number as the number of protons present in an atom. While the atomic mass was defined as the number of protons and neutrons present in an atom. Remember, we also said that the number of protons in an atom is equal to the number of electrons in the same atom. For as long as we are dealing with an atom, the number of protons, which is the atomic number, is equal to the number of electrons in the same atom. So what does this mean about our atom chlorine? This means that because our atomic number in both cases is 17, then chlorine 1 and chlorine 2 have the atomic number is 17, the number of protons is 17, the number of electrons is 17. From the mass numbers, when our mass number is 35, and you know the mass number we have said is the number of protons and neutrons. Already we've said our protons are 17. So the number of neutrons here will be 35 minus 17. And therefore, chlorine 1, chlorine 35, has 18 neutrons. While chlorine 37, where the mass number is 37, and the number of protons are 17, when we subtract 37 minus 17, we get the number of neutrons in this case to be equal to 20. We can get the number of neutrons in this case to be equal to 20. What can we conclude about this? We can say that chlorine has two identical or almost identical atoms. We can see two atoms of chlorine here. We have chlorine 35, and chlorine 35 has 18 neutrons, while we can see chlorine 37, which has 20 neutrons. From this observation, we can see that they have the same number of protons. But when it comes to the number of neutrons, their number of neutrons differs. Chlorine 35 has 18 neutrons, while chlorine 37 has 20 neutrons. These are atoms of the same element, chlorine, with the same atomic number, 17, and different mass numbers, 35 and 37. Otherwise, we can also say that these are atoms of the same element, chlorine, with the same number of protons and same number of electrons, but different number of neutrons. 18 neutrons against 20 neutrons. It is this difference in the number of neutrons that is making the mass number or the atomic mass to be different. I want us to note that it is this difference in the number of neutrons present in their nucleons that makes the mass number of these two atoms of chlorine to be different. Such atoms are called isotopes. So how do we define isotopes? Isotopes are two or more atoms of the same element with the same atomic number but different mass numbers. I'll repeat. These are atoms of the same element with the same atomic numbers but different mass numbers. Or we can also define it as isotopes are atoms of the same element with the same number of protons and electrons but different number of neutrons. Is it possible that we look at some other examples? Yes, we can. In this case here, we are having our atom as carbon. You can see we have carbon 13 and we have carbon 14. Carbon 13 and carbon 14, both of them have 6 number of protons and they have 6 number of electrons. But when we get to the number of neutrons, carbon 13 has 13 minus 6, which gives us 7 neutrons, while carbon 14 has 14 minus 6, which gives us 8 neutrons, So we can confirm that carbon, we have atoms of the same element here, carbon 12, carbon 13, and carbon 14, with the same atomic mass. Their atomic masses are the same, but they have different atomic masses with the same atomic numbers, but different mass numbers. Our atomic numbers here are 6, and the mass numbers, we have mass number 12 for carbon 12, mass number 13 for carbon 13, and mass number 14 for carbon 14. So we can say that atoms of the same element having the same number of protons and electrons but different number of neutrons are also called isotopes. I want you to note that isotopes could have the same, in fact, isotopes have the same chemical properties. Chemical properties is determined by the number of valence electrons. And because their atomic number is the same, they have the same number of protons, they have the same number of electrons, then their electron arrangement is the same. And in this case of carbon, our electron arrangement is 2, 4. All the three isotopes have the same electron arrangement, have the same valence electrons, and therefore they react in the same chemical manner. However, because of the difference in the atomic mass, then they will have different physical properties. Let me use an example, water molecule. If I'm dealing with a water molecule which has two atoms or two elements, which is made up of two elements, hydrogen and oxygen. And we used a hydrogen with atomic mass of 1, while oxygen with atomic mass of 16. Then the mass of this hydrogen molecule will be 2 times 1 plus 16, which will give us what? 18. But if we changed our isotopes of hydrogen and oxygen to maybe isotope of hydrogen, hydrogen 2, so 2 times 2 will give us 4, plus oxygen at atomic mass of 18, then 4 plus 18 will give us 22. So you can see that our atomic mass is changing, or the mass of our molecule of water changes from 18 to 22 because of a change in the isotopes, of their individual elements making up the molecule. This is just a confirmation that we have the different number of, for us to talk about carbon 12, then we have the summation of the number of neutrons and protons which make up the nucleons. Carbon 13 is made up of 7 neutrons and 6 protons. Carbon 14 is made up of 8 neutrons and 6 protons. Let's look at another example. In our example, we are now looking at sodium. We have two isotopes of sodium, sodium-23 and sodium-24. All of them have the same atomic number, 11. So that makes their number of protons to be 11 and their number of electrons to be 11. However, sodium-23 has a mass number of 23, and this makes the number of neutrons to be 12. When you get 23 minus 11, we get 12. While sodium-24 has a mass number of 24, and if we subtract the atomic number 11, we get the number of neutrons contained in the sodium atom, sodium-24, to be 13. So we can see they have different number of neutrons. They have the same atomic number, but they have different atomic mass. So these two are isotopes of sodium. Next, we shall look at an isotope of oxygen. We have 3 isotopes of oxygen: oxygen-16, oxygen-17, and oxygen-18. Oxygen-16 has 8 protons against 8 neutrons, and our mass number is 16. Oxygen-17 has 8 protons against 9 neutrons, therefore our mass number will be 17. Oxygen-18 has 8 protons against 10 neutrons, our mass number will be 18. Next, we shall look at isotopes of lithium. There are 3. You can see the blue color represents here the protons, the brown color represents the neutrons, and therefore lithium 6 has a number, the mass number, the total sum of the protons and the neutrons to be 6, 3 protons and 3 neutrons. So our mass number is 6. For lithium 7, we have 3 protons against 4 neutrons, so our mass number is 7. Lithium 8 has 3 protons against 5 neutrons. That makes lithium 8. So these are isotopes of lithium. Already you have heard me talking about isotopes of hydrogen. Hydrogen 1 does not have any neutron in the nucleus, and therefore it only has a proton. That's why the mass number is 1. Hydrogen 2 has a mass number of 2. It has 1 proton and 1 neutron in the nucleus. Hydrogen 3 has a mass number of 3. It has 1 proton and 2 neutrons in the nucleus, and therefore the mass number is 3. So these are isotopes of hydrogen. These are isotopes of hydrogen. This is just confirming that the isotopes of hydrogen are made up of what we've discussed. And finally, we have isotopes of beryllium. It doesn't mean that this is the last of isotopes. We have even more isotopes like argon, uranium, helium. So these are just examples. I therefore take this chance to thank you for being our listeners and taking time to study in our lesson. I wish to meet you in our next lesson, where we shall be talking about isotopes and relative atomic mass. It was a pleasure having you. Thank you so much.